Yes, so last time we did something to do with soldering. Now I thought that I should make mention of the concept of desoldering. Now, usually desoldering is much simpler than soldering, depending on what works best for you. But desoldering, we begin from reviewing what soldering was, and we realized that soldering was gluing two metals together in a manner that they are able to conduct it using soldering wire. So the soldering wire is basically a molten metal that joins the first wire to the second wire so that electric current can flow through that wire or conductor. Now, the soldering is the idea of removing that solder so that you can separate the two. And where does that help you? It sort of helps you in removing components. And you may be wondering, why should you be removing components? And usually you're removing them so as to replace the dead ones, and also so as to recycle the components that are from older circuit boards, because there are circumstances where you want to do a replacement of the component, however you can't find it as a new component on the market, so you have to pick it from another motherboard that probably is dead of something else, but function with other components. Now I wanted to just show you the tools that you may need when removing solder. Now, of course, the tool, it's obvious that you need a heat source, in which case we need that soldering iron, right? And then, of course, at times you may need solder itself, since you need to soften the existing solder. And then there is a third tool, which is called suction tool. This helps suck the molten suction. All right, what's the spelling of suction? Suction tool. This helps in sipping out the molten solder. Here, melted. So now let's pick one of the components, or the donor of the components, just to demonstrate. So I am going to use some old power supplies that got damaged. Now let us look at, for instance, this. So there are times perhaps you want to use this capacitor to do your job, or at times probably that diode right there, the black thing, it's functional and you need to salvage it and use on another device. So anyway, that's where the soldering would come in. Anyway, so assuming you didn't have what should I say, you didn't have the suction tool and we needed to remove this component, first you should be able to hold it and rip it off, but this looks glued. Anyway, let's pick another one that is not that stuck, and that's for instance this one right there. So for you to be able to desolder, you have to identify what are the contact points of the terminals of that component. Now capacitors tend to have two contact points, the negative and positive. So you just look at this and then look at below it. There's 1, 2. Like you sort of use your eye to estimate. Look at this while looking at that side, and whatever lens is likely the contact points. So from my case, it's this and that. Now I haven't yet plugged in my soldering iron. I need to plug it in so that it gains heat, such that I may do that for you. So let me let it heat up. Alright, so we were removing this capacitor, and one, you have to have grip on it, and then 2, melt the 2 terminals concurrently. That should keep them molten, and this comes out. So that's how you salvage components from previously failed boards that have certain components that do survive, have health. Then that doesn't also rule out the idea that you will have to test the components, in as much as physically they show no sign of damage. Now this is a capacitor. You would measure it with a capacitance meter to confirm its rate of charge and discharge, and then also to confirm the internal resistance. If it builds up with time, then you know it charges up. Alright, now there are components such as this that might have 4 terminals. Now this is a surface mount, the other one was a pin through. In other words, it comes in on the underside, and then its solder terminals push through the print circuit board. Now this one simply sits on top, so it's mounted on top or on the surface, hence the moniker surface mount device, SMD. Now the idea in dealing with something like this, a surface mount that is more than 2 terminals. Now if you look at this, this is a resistor, it's a surface mount resistor. Now the pin through resistor would be this one, which has color bands to allow you read the resistance values, the first 2 being the first figures, and then the last band being the multiplier. There's a color code, sort of, that will be a video for another day. However, for surface mount, they tend to have a minimum of 3 digits written on it, if it has area enough for it to be read. The first 2, you write them the way they are, and then the last one is a multiplier, so you multiply the first 2 by 10 to the power of the last figure. Or you could just say you write the first 2 digits and add a number of zeros that correspond to the last figure. So for instance, this is let me zoom in so you may see. For instance, this is 221, so I could just write 22 and add 10. That's 220 ohms. Consequently, if you look at this, this is 754. That is 75 plus 4 zeros, or 75 times 10 to the power 4. Yeah, that was a little detour. I believe every story needs a little digression, but let's get to what we're trying to do: desolder a surface mount device that has more than 2 terminals. But before I could demonstrate that, let me do that with a 2-terminal surface mount device, which is our resistor here. So you could hit this side quickly in succession. That's because you want to melt the side while that side is still molten, and you can see that I've knocked it off. The alternative would be using a hot air gun, delivering a temperature of around 300 degrees Celsius to melt both terminals at the same time as you pick it off the board using tweezers or forceps, depending on your field. Now, what I just did to this can be done to this. However, how do you do that? You do that by adding solder here and there. I'm with the soldering wire. I think you held it at some point. All right. So this is a soldering wire. So what you would do is add solder to those 4 terminals so that it joins all of them, so that it provides a platform to deliver heat onto all the 4 terminals concurrently. So then we do that about it, and just like that we knock it off. Now if you had to salvage this component, that means having to pick off that excess solder you had placed on the terminals. And what you might not know is that with time, if you use flux, you notice that solder tends to prefer to coalesce onto more solder. So if you have solder at the tip of the soldering iron, naturally when you come to swab on those terminals, it will absorb that solder, and then you can reuse this surface mount component. I believe this is the IC that manages the feedback mechanism between the output to the and the input. It's called switching power supply because it has to maintain the output at a constant wattage. So if the input voltage drops, because at times we might have power fluctuations, the thing can survive at voltages as low as 100 volts, as high as 230 volts while maintaining an output. So you'll find that your charger can charge your PC even when your bulb looks dim. That's because it switches its output resistance to allow more current to flow so as to maintain the wattage. And yeah, that's just a highlight of how this, but anyway, the whole idea was how to desolder. Anyway, I think in the next video I will upload, and someone will be demonstrating how to desolder components, just to give you a feel of how to go about it from the point of view of someone who has never done it, so you may have the courage that these things are quite doable. And the more you do, the more, I could say, you may develop muscle memory. So you do certain things without really critically thinking about it. For instance, okay, case in point, if you've ever ridden a bicycle, in the early days of practicing, you literally pedal while looking at the pedals, but with time just happens while you're looking at the greenery, receiving a text from a smartphone. Anyway, so that's the beauty of practice. It's something that becoming subconscious. All right, hit the subscribe button, and feel free to come back. Next video comes back soon. See you.